welcome to the deep dive. Today, we're jumping into a place where math, specifically the kind you might be seeing in calculus class,
Yeah.
really mates the real world,
Mm-hmm.
agriculture, actually.
That's right. We're looking at a text today that digs into a pretty cool connection.
Yeah.
It's about using mathematical tools, things like differentiation and integration, to calculate something very practical.
Okay, like what?
The total energy animals use. Specifically, animals in rotational grazing systems on farms. You know, how much energy they burn.
Ah, okay. So like sheep or cows moving around a field, eating grass.
Exactly.
And they're using energy constantly, right, with every step, every bite.
Right.
So our mission here in this deep dive is basically to unpack how that math concept integration lets us actually, put a number on the total energy they use, making that link between the textbook and the field, sort of.
Precisely. And it's important because, think about it, an animal's energy use, it's not just one steady number.
No, definitely not.
It changes all the time. Depends on, the ground they're on, how fast they're moving.
Whether they're just standing or walking or actually grazing.
Exactly. So at any single moment, there's a rate of energy use, an instantaneous rate.
Okay, and that rate is always fluctuating.
Yeah.
So differentiation, that could tell you the rate at one specific instant, maybe?
Yeah, it helps understand that immediate rate of change.
But the big question is, how do you figure out the total energy burned over, say, a whole afternoon? Like 8 hours in one part of the field.
And that's exactly where integration comes in. Our source really highlights this.
Right.
If you can somehow model or measure that changing rate of energy use over time. Integration is the tool that lets you essentially sum up all those tiny instantaneous rates across the whole time period you care about to get the cumulative total.
Like adding up infinitely small slices of energy use.
Kind of, yeah. It's like finding the area under the curve if you graph that energy rate over time.
Okay, conceptually that clicks. Summing up the bits to get the whole picture. But here's where I get curious, based on the text. How do you even get that rate, that function of energy use for, a cow walking around?
Yeah, that's a really key practical challenge this source talks about. It involves collecting data, lots of it.
Like what kind of data?
Well, the text mentions using tech like GPS trackers, for instance, to measure speed and distance covered.
Okay.
Maybe accelerometers, too, to get a sense of the effort, like if they're going up slopes.
Right. More effort, more energy.
Exactly. And you might even factor in environmental things, temperature, wind. They can all influence how much energy the animal needs to spend. So researchers use all this data to build a model, like an equation for that energy expenditure rate, let's call it ET, over time, ET.
Yeah. Okay, so it's not just some neat textbook integral problem.
No.
It's an integral applied to a really complex function built from actual field data.
Precisely. And the reason why this is done, the source points out, is super important for things like optimizing rotational grazing.
How so?
Well, if you know the total energy expenditure, farmers and researchers can figure out nutritional needs much more accurately.
Gotcha. Make sure they're getting enough feed.
Right. Or compare different pasture types. See which ones are more efficient energy-wise for the animals or different grazing patterns. It helps manage resources better, improve animal welfare.
It turns something that seems kind of random animals wandering a field into something you can actually measure and analyze.
Yeah, it makes it quantifiable. That integral science suddenly represents real, practical insights for farming.
That really does put the math in a different light.
It really shows how calculus gives us the language, the quantitative tools needed to analyze these dynamic systems, whether biological or agricultural.
So, thinking about you, the listener.
Yeah.
What this really means is that these powerful ideas you're learning, like how to set up an integral or interpret what it means, they're fundamental tools. They pop up in fields you might never expect, like animal science or sustainable agriculture. It's not just abstract math.
Absolutely. Understanding how to model a rate of change and then accumulate its effect over time. That's a skill with applications far, far beyond just the classroom.
Definitely. So maybe here's a thought to leave you with from this deep dive. As you learn more math tools, keep asking, how could this tool be used? How might it help understand something dynamic or something that adds up over time in a field you're interested in, even if it seems totally unrelated at first glance?
Look for those unexpected